Cool, we're at Nmap Live Host Discovery. So, this room is important. Explains the step Nmap takes to discover online system for port scanning, which is crucial because attempting to port scan offline system will only waste time and generate unnecessary network noise. Okay, subnetworks. Okay. So it's about subnetwork. Yep, that's what it says. So subnet, this is a subnet mask, which means system bits were used for these masking. The rest of the system bits are used for identify different hosts. Sending for 24/24, 24 bits for subnet mask, the rest of 8 bits for identifying the host. And if you are using ARP to discover devices, you won't be able to see other devices in other subnet because ARP query won't be routed and therefore cannot cross the subnet router. It's a link layer protocol and ARP packet are bound to their subnet, which is saying the network A, devices network A, will not be able to see the device in network B using ARP request. So, question: how many devices can see an ARP request using this? Okay, computer 1 using ARP request. Data, we can do computer 6. What computer 6? Oh, to computer 1. Because we're asking for computer 6. Oh, okay, I see. Send packet. So only 4 devices, including the router. Do not count a switch when counting devices. Do not count switch. But it's a void. Wait, go again. Then that'll be 3. Oh yeah, no. Yeah, that is good. Including the router is 4. Did computer 6 receive the ARP request? No, it stopped at the router. Computer 4 to computer 4 ARP request. Computer 6. Okay. How many devices? 4. Yeah. Oh. Yeah. Wait. Yeah. Okay. Enumerating target. So it's saying some example usage of a map over here. You can provide the range of IP. You can provide the subnet mask. You can also do, what's this? A list. The IP, the domain. Yeah, you can do a list. You will scan 3 IP addresses. 3 over here. So question, what is the first IP address and map will scan if you provide that? Okay. So the way I like to think about this question is, we have 29 bits of submask, right? So we have 3 other bits for host. 2 to the power of 3 is 8. So it range from 10.10.12.13.0 to 10.10.12.7, and then from 7 to 15, right? Actually, from 8 to 15 and then 16 to 24, and so on and so forth. So 8 is the each portion is 8. So 13 belongs to the second portion, and the second portion started from 8. So that would be the answer. Or you can just run the map. Sure, let's do that. Map -sl-n 10.10.12/29. Yep, it will scan 8 devices from, see, that's what I was saying, 10.10.12.8 to 10.10.12.15. That's a section. Do another experiment. If you scan 28, 30. Huh? Oh, okay, so yeah, 8 of them. But if you do, say like 19 that belong to the third section, which started from 10.10.12.16 to 24, and then 25 to 33. So that's the third section. This will unmap. If you run this, unmap will scan IP range from 10.10, the 12, the 24 to 31. Sorry. Yep. How many IP will unmap scan if you provide the following range? 24, 10.10.0, 25. There's a different notation. Well, understand this. I don't understand what this means. 10.10.10.0/20 -25 to 255. Okay. -255. Wow. 64. Stealth and 400. I mean, what does that even mean? Only one value. Oh, okay. So there's arctech value. So each dot is arctech. 10.10 dot from here to here. Okay. So I guess you have to multiply those. Yeah, 256 to 25. Okay, I see. All right, next. Discovering live host. So, network layer. ARP is a link network layer, a link layer. ICMP network layer. TCP UDP transport layer, and the rest application layer. Just a recap. So we're back here. Question 1: what type of packet did computer 1 send before the pin? So computer 1 to computer 3 pin request. Computer 1 to computer 3. What's 3 here? I think they're ARP request, but we'll see. Yeah, ARP request, because he doesn't know where computer 3 is, right? So it will be your first broadcast, the ARP request to everybody asking, where is computer 3? Computer 3 receive that message, reply back, I'm here. Other laptop, other devices will just drop the packet. That's what it does, right? See, sending to them. Oh wait, switch already learned the devices, so it won't broadcast it anymore. What type of packet did computer 1 receive before it was able to send a pin? What type of packet did computer 1 receive before it was able to send a pin? Is it an ARP request? ARP response? Yeah, from computer 3. How many computer respond to the pin? Just one. Send a packet with the following. Computer 2 to computer 5 using pin request. What is the name of the first device that respond to the ARP request? So computer 2 to computer 5. You want to pin it. What is the name of the first device that respond to the first ARP request? Is it switch? So computer 2 send ARP request to everybody, asking where computer 5 is. Drop it, send it to router. Let's see. I see. So router hey computer 1, I'm computer 3. No, that's not. Sending. Okay, go. I'm a local network. Okay. Computer 1 receive pin response. Okay. Computer. Who has router? Tell computer 2. Hey computer 2, I'm router. Okay. Sending pin request packet from computer 2 to computer 5. Who has computer 5 tell router? Can we do that again? Computer 2, wait, what? Computer 2 to computer 5, pin request, you sent. So router says I know. Router says this is router. Router send ARP request everybody. Computer 5 reply. Router send pin request, and then router send the pin response back. So what is the name of the first device that respond to the first ARP request? Isn't it switch 1? Or router? Okay. What is the name of the first device that respond to the second ARP request? The name of the first device that respond to the second ARP request. Is it switch 2? Computer 5. Send another pin request that it requires new ARP request. I assume no, because it already knows everybody's. Nah. How would you know which hosts are up and running? So, when running a Nmap scan, if you are privileged users, meaning you are root or your sudoers, Nmap will use the ARP request when you are scanning the local network. When you are privileged users, but you are trying to scan the target that outside of the local network, Nmap will use ICMP echo request, TCP ACK to port 80, TCP sync to port 443, and ICMP timestamp request. If you're not a privileged user, Nmap will use TCP three-way handshake by sending SYN packet to port 80 and 443. So it's important to know what Nmap is doing under the hood. And before we scanning, as it says at the beginning, it's essential to avoid wasting time to do the port scanning to an offline host. So how do we know who's on the network? Well, ARP request, right? And we can do an ARP scan without scanning the port. So we just want to know who's on the network. That's all. We can run this nmap-pr-sn with the target IP. So basically what it's doing is it will be sending a bunch of ARP requests to the host on the network. And because those hosts will reply back when they are on the network, so the Nmap will be able to know who's on the network. There's also another tool called ARP scan, which is a different tools, but does probably similar things. It's called ARP scan, ARP-scan tool. It's not installed by default, but we can do it by running this command. So from computer 1 to computer 1 ARP request. Try all 8 devices on the network 2, 3, 4, 5, 6, switch 1, switch 2, and the router. How many devices can you discover using ARP request? So I'm guessing you can only know 1, 2, 3, 4, including switch and the router, because ARP requests will not be able to go out of the local network. By local network, I mean routers. Okay. No, so maybe 3, not including the router. So 3. Yeah, because the router is not. I guess it's not part of the network. Okay, so ICMP, Nmap Host Discovery using ICMP. So one thing we need to know is many firewalls block the ICMP echo. For example, MS Windows, they are by default configured with the host firewall that blocks ICMP echo request. There are a few ways that we can use ICMP. In Nmap, we can send echo request, which is using -PE option, or we can do, since echo requests are often blocked, we can also do ICMP timestamp request, which is done by using -PP option. And lastly, we can also do this by sending -PM, which is using the ICMP mask query. And if you don't know what that is, it is a deprecated ICMP query message used by the network devices to discover the subnet mask. So something ICMP used to find out the subnet mask, and it's deprecated, so I don't know if that's still being used. Well, I didn't know that either, so I Google it. Alright, question. Oh, one thing I think is interesting is that, so if we look at the first example here, using Nmap echo request, if you're scanning the same IP, the same subnet mask, right? The Nmap will first send a ARP request before it even send the ICMP request. So that's how we know the MAC address in this testing, in this example. But if we're sending same request, see, option are the same, but in a different subnet mask, right? 1010, 68, 220, 10, wait, that's the same. Or maybe, maybe because we are in a different subnet mask, perhaps. Yeah, it says here, this time we will scan from the system on a different subnet. So in this case, Nmap still, maybe it still sent an ARP request first, but it didn't find the answer, so it will proceed with a ICMP request. And this time we don't get to see the MAC address like we did up here. So question, what is the option required to tell Nmap to use ICMP timestamp? So I think that's -PM. No, okay. Somewhere times PP. ICMP address mask to discover the live host. So it's -P PM. Okay. What is the option required to tell Nmap to use ICMP echo to discover live host? So that's -P, I think N? No, okay. It's -PE. TCP UDP. So Nmap Host Discovery using TCP UDP. So TCP uses three-way handshake, right? SYN, ACK, and in Nmap we can see if a host is alive by sending a SYN request, because it's supposed to send back the SYN ACK request. We can also specify the port. Some service might not be run default on 80, right? They might be running other ports. We can do that by using the -P option, -PS option. We can also use TCP ACK pin, right? ACK request. When you send the ACK request without a preceding SYN ACK request, the server will reply with the reset request, RST. So that's also one of the ways to see if that is the host is alive. And lastly, UDP pin. So when we send a UDP pin, if the port is open, it will not reply anything. But if the port is closed, we will get an ICMP destination unreachable message, which is kind of saying the port is not there, right? So if we didn't get a message, there's a way of saying that the host is alive. And lastly, there's a tool called MassScan, which is kind of like scanning tools like Nmap, but it's more aggressive, generates more packets, allow us to scan different ports. So which TCP pin scan does not require privileged account? So that's gonna be SYN ACK SYN ACK pin? No. TCP is that's in the very beginning. Yeah, TCP's sync pin. Which TCP ping scan requires a privileged account? TCP ACK ping. No. I spelled wrong. CK. What option do you need to add to Nmap to run the TCP sync ping scan on the telnet port? So you can do -ps telnet port. I think it's run on, what was it, 43? Oh, 23. 43 is... Yep. Using reverse DNS lookup. My default behavior is to use reverse DNS online host because the hostname can reveal a lot. This can be helpful. However, if you don't want to send such DNS query, use -n to skip this step. By default, Nmap will look up online host. You can use the option R to query a DNS server if you want to use specific DNS server. Okay, so you're saying you can skip a DNS query by having this option in, or you can specify what DNS server you want to use by using option R. Oh wait, no, by using this option. So -R is to query the DNS server even for offline host. We want Nmap to issue a reverse DNS lookup for all possible hosts on a subnet, hoping to get some insight from the names. What option should we add? So it's on a subnet. I guess would be -R. Yep. Summary. So we've walked through all these different type of scan in Nmap and so many different options. So make sure you have taken Nmap option explaining room to continue learning about Nmap. Okay. I will see you in the next room.